Have you ever looked at a program and just wondered what's going on under the hood? Especially when you don't have the source code? Well, that's exactly what we're diving into today. We're going to crack open a program and hunt for the secret that's locked away inside. So here's our mission, should you choose to accept it. We've got this C++ program, and it's guarding a secret. Our job? It's to figure out what that secret is, without the program just, handing it over. We've got to earn it. All right, so how are we going to solve this thing? We're going to use a super cool technique called reverse engineering. The best way to think about it is like digital detective work. Seriously, we're taking a finished product, a black box, and working our way backwards to figure out its blueprints, its logic, and most importantly, its secrets. Okay, let's put on our detective hats. We're diving into our first section here. What does it actually mean to be a digital sleuth? And maybe more importantly, why is this skill so incredibly valuable? Oh, the applications for this are huge. I mean, this skill is absolutely crucial for so many things. We're talking about understanding how software protection works, crushing it in challenges like CrackMe's and Capture the Flags, all the way to the really critical job of analyzing malware to keep all of our systems safe. And hey, on top of all that, it's just an amazing way to sharpen your own programming logic. Right, so every good detective needs a case file, and this is ours. It's a pretty simple C++ program. Its one and only job is to guard a secret. It asks you for a key, and then it decides if you're worthy. Our goal is simple, but not easy. Find that key. All right, let's get to it. Time for our first inspection of the crime scene. We're going to take a close look at the code's behavior to get a feel for what we're really up against here. So this program is pretty straightforward. It really only has two possible outcomes. You give it the right key, you get access granted. Simple enough. You give it anything else, you get hit with invalid key. Our entire investigation, everything we're about to do, is all about finding the one specific key that unlocks that access granted message. Okay, after taking a look at the source code, we've got a prime suspect. It's this one function right here called check key. This, my friends, is where all the magic happens. It takes your key as input and spits out a simple true or false. This is the black box we need to crack wide open. And now for the really fun part. We are going to dissect that check key function piece by piece and follow the trail of clues hidden right there in the code. This is where the real detective work begins. Let's go. So, the logic inside this function, it's basically a four-step security checkpoint. First, it checks the key's length. Then, it loops through every single character. After that, it applies a simple cipher. And finally, it calculates a very specific kind of sum. Let's break down each one of these steps. Clue number one. And this is a big one, folks. The very first thing this function does is check the key's length. If it's not exactly 8 characters long, not 7, not 9, it fails right then and there. So what does that tell us? The secret key has got to be 8 characters long, period. Okay, on to clue number 2. We see this for loop. And notice, it runs exactly 8 times. This just confirms what we suspected. The program is going to process each of those 8 characters one by one. Every single character has a specific role to play in this puzzle. Now we're getting to the real meat of it. Clue number 3. This line is the core of the whole cipher. For every character in our key, the code does what's called an XOR operation with 0x41. Now don't let the name scare you. Just think of XOR as a simple way to scramble a value. And that 0x41? That's just the hex code for the capital letter A. It's a classic trick, really, just to obscure the logic a little bit and make it tougher to figure out at first glance. And here's our final clue, the weighted sum. So that scrambled value we just got from the XOR operation, it doesn't just get added to a running total. No, that would be too simple. First, it gets multiplied by its position in the key, plus 1. So the first character's value gets multiplied by 1, the second by 2, and so on, all the way up to 8. Now, why would they do this? It's clever, actually. It makes the order of the characters absolutely critical. You can't just have the right characters, you need them in the right sequence. It's another layer of security to make the key much, much harder to guess. Okay, let's recap. We've gathered all our clues. We know the key has to be 8 characters long. We know how each one of those characters is scrambled and then added to that special weighted sum. Now, let's see how all of these pieces fit together to finally unlock the secret. So after the loop finishes its job, after it's processed all 8 characters and that final sum has been calculated, the program has one last test, one final hurdle to clear before it gives us what we want. And here it is, the whole thing. That entire complicated calculation, the length check, the character loop, the XOR cipher, the weighted sum, it all comes down to this one simple question. Does that final sum equal 1337? If the answer is yes, then congratulations, you found the correct key. 1337. This is it. This is our magic number. The entire security of this little program rests on finding a key that, when you push it through that specific formula, gives you the number 1337. We've done it. We've cracked the logic. So, we did it. We've successfully reverse engineered the program's validation logic. Case closed, right? Well, in the world of reverse engineering, finding the formula is really just the beginning. So the big question is, what comes next? Well, the obvious next step is to use this formula to actually find the key. And that means we'd have to reverse the math we just figured out to create something called a keygen, a little program that just spits out valid keys for us. We're also going to talk about how to really develop that true reverse engineering mindset, which is the ultimate goal here. And don't worry, we are going to cover all of that in our next explainer. So, I'm going to leave you with a little challenge. We have laid out the entire blueprint for what makes a valid key. You know the length, you know the formula, and you know the target number. The only thing left is to find a key that actually works. So now that you know the secret formula, what do you think the key